Welcome back. Here we've got two more equations involving trig functions, but now there isn't a single expression with a trig function that we can isolate and then undo to solve for x. Now we've got several terms that have a cosine in them. So one thing that we did before was, if you sort of look at this, it kind of looks like a quadratic, especially if I hide it with my fingers like this. So it looks like there's 3 times something squared minus 2 times something minus 1. So if that feels quadratic, it certainly is. Let's make a substitution. If cosine x is p, then instead of 3 cosine x squared, it's really 3p squared. And instead of minus 2 cosine, it's minus 2p. And now it definitely is a quadratic that you can solve. You can always try and factor. If it doesn't work to factor, you can try and complete the square, and you might need to do either of those things. In this case, it does factor. So I know I'll need a 3p and a p. Over here, I need two things that will multiply to be negative 1. So I know it's going to be 1 and 1, and one of them is going to be negative, and one of them is going to be positive. If I need to end up with a negative 2p, it makes sense for this one to be negative, because that's going to give me negative 3p, and then this one to be positive, which will add 1 to give me negative 2. Okay, so this gives me two solutions. Here I've got 3p plus 1 equals 0, or p minus 1 equals 0. So that means p is 1, or p is negative 1/3. All right, what was p? P was cosine. So cosine x is 1, or cosine x is negative 1/3. Let's think back in terms of the unit circle. So we're looking for angles whose x-coordinate is 1. This is the only place where on the unit circle where the x-coordinate is 1. So this is just going to be 2 pi k, where k is an integer. And that gives me the angle 0. It gives me 2 pi. It gives me 4 pi. It gives me 6 pi. All the angles that end up here. Okay, what about this side? So this side, cosine is negative 1/3. That does not correspond to any special angles we know, but they're happening approximately here and here. So in this case, I can say x is inverse cosine of negative 1/3. That's going to give me this angle right here. Remember, I can add 2 pi k. How do I get this other angle down there? Well, it looks like it's the same angle wrapped in the other direction. So rather than say x equals this, I could say x is either plus or minus the inverse cosine of negative 1/3. And the way you want to think about that is, think about this entire thing inside the blob as a single number that represents that angle. And then it makes sense to say what would be the opposite of that angle. I could say negative this entire blob, and that would be the same angle but wrapping in the other direction to take me here. And then don't forget, either of those positions, you could add a full circle and still get to a point that satisfies that equation. So again, plus the 2 pi k. All right, so big takeaways here. We have this business from the last video. The only new thing was realizing that you can make a trig substitution. Okay, what about this side? How is this side different? Well, if I wanted to try and say p is cosine theta, I could substitute here, but then I've got some signs. If I wanted to try to say that p was equal to sine theta, or x in this case, I could substitute here, but then I wouldn't know what to do with cosine. So what makes this side different is I have two different kinds of trig function, and that makes it awkward to make a single substitution. So a nice thing you could do is, let's use the trig identities that we've learned to turn the sines into cosines. So we talked before about sine squared being the same as 1 minus cosine squared. So I'm literally going to make that substitution. And now this equation on the right is just like the equation on the left. Now I can say cosine x equals p, and I've got 1 minus p squared, 2p, 2, and 0. So let's try and solve this the rest of the way and see what happens. So I've got 3 minus 3p squared minus 2p plus 2. So I'm noticing I can combine those two as 5. At this point, you could decide to factor or complete the square. I kind of dislike having a leading coefficient that's negative, so I'm going to multiply both sides by -1. So that gives me 3p squared plus 2p minus 5 equals 0. And now I'm going to try and factor that one. So that can be 3p and that can be p. I know I need two things that multiply to be -5. So that can only be 5 and 1. Let's put them here. So now I'm thinking that doesn't make much sense because 3 times 5 is 15, but that's a very large number, so I'm not going to get to 2. So let's try it the other way. 1 and 5. So now 3 times 1 is 3. How am I going to get to 2? Well, I could get to 2 if this was -3, and then I'm adding 5. So -3p plus 5p is positive 2p. And then 5 times -1 is still -5. So that seems to have worked. All right, so I've got 3 cosine x plus 5 equals 0, or cosine x equals 1. On the cosine x equals 1 side, that gives us, again, you could sketch a little unit circle. We're looking for x coordinate 1, which is here. So that's just 2 pi k, where k is an integer. What about this side? I've got cosine x is -5/3. If we think on the unit circle, what's an angle whose x coordinate is -5/3? Well, -5/3, it has a larger magnitude than 1. It's past -1. So this doesn't correspond to any points on the unit circle. So there are no solutions that come out of that branch. So that would be the full set of solutions. So the big takeaway here was, if you have an equation with more than one kind of trig function, try and make substitutions so that there's only one kind of trig function, and then you can solve it using other techniques.